All right. For today, all I want to focus on here is something called the squish theorem. Cool? So I'll give you a moment to kind of like write this down. Let's read it together. Let's try to digest this information. Here is what the squish theorem says, and there is like a visual representation of what it's saying to make sure that you can really digest what's happening. Cool? So essentially, the squish theorem. Here's what's very important. I have 3 functions, cool, such that one of them is the smallest one, and then you got like a middle one, and then you got a larger one, or they could all be exactly the same. Are you with me? Okay, that's going to be key for this. But here's the key to it. It says for all of the x's in some interval, except possibly at c. Now, why? Well, I'm taking limits, as you can see down here, at c. Does c have to exist to have a limit? No. So technically that's true. Cool. It just has to be, this has to be true everywhere else except possibly at c. Cool. It says that if the limit of the smaller function is L, and the limit of the larger function is also L, then logically, the limit of the middle function has to be L. Just logical. Because it's squeezed in the middle of the other two. Like this diagram is showing you, right? G and X. G happens to be larger everywhere else. H has to be smaller everywhere else. And then f of x is squeezed right in the middle of the two. Cool? Now somebody asked me in another class, like, wait, does it have to be like that they're all going towards like L? Like, could it be that maybe I have F like up, I'm sorry, what is it? G like up here, and then like F not touching but here, and then the other one below it. And I'm like, well, technically, yeah, that would be true, but you wouldn't have this equal part, right? They'll just be less than each other, right? The problem with that is the definition of a limit says that it's supposed to approach a unique value, right? If you have a scenario, again, which you have some function here, the other function here, and then the function here, and this is the c value, well, would you agree this is going to a different y value? This is going to a different y value. So like, let's say hypothetically this was like x equals 4, I'm sorry, y equals 4, and this was y equals like 7. Then, are you going to be able to tell me anything about the middle function? You're just going to be able to tell me like, hey dude, all I can tell you is it's between 4 and 7. But are you going to be able to tell me what the actual limit is? No. So, does it have to be that they're basically almost approaching the same limit in order for this to work? Yes, in order for this to work, it has to. Because look at the requirement. If it says, if this and this are the same. If they're different, then you cannot tell me this statement. However, just for the purposes of math, if this are different, you could at least tell me, hey, I can't tell you the limit, but I can at least tell you it's in between here. Fair enough? Okay. Any questions on that before we do like an actual example? All right. I'm going to pick something that I think it's similar to one of the questions I have already assigned for homework, which I think this question was on WebAssign. It gave you sine or cosine of a graph, and then it gave you the picture, and it was like oscillating, and then it went crazy, and it was asking what is the answer, and the answer was does not exist. It's very similar to this. The only thing I did it differently is I put an x in front of it. Let's see if putting that x is going to make a difference. Ready? Okay, first, by substitution, putting in a 0 here. That makes it 0 times something, right? Would you agree with me that 0 times anything is equal to 0? Yes?
Yes.
Okay, careful. Vocabulary matters. I said 0 times anything. What does anything mean?
0.
It could be so it has to be 0 times a number, not like the word anything is so like, wait, what does that mean? You gotta be very careful. I need to know what's happening here. This needs to exist in order for me to 0 times a number. What's 1 over 0? take the sign of something undefined. So I can't really just from the get-go say that 0 times this undefined value is gonna produce a 0. It could. I'm gonna be honest. It more than likely will, but you gotta make sure it does. Cool? So, here's the problem. I don't see how I'm gonna factor this. I don't see how I can use a conjugate. I don't see how I can simplify this. I don't know any trig identities that is going to help me break this into anything else. But here's what I know. From trigonometry, I learned this thing called sine. And in order for me to find a sine, it's called a sine ratio. I need to input angles. You remember that part? You input an angle so that it can give me an answer. Agree? By substitution, isn't that what we're doing? We're putting in something so that I can get a number out. So I need to input angles, right? So I can get a ratio out. So in other words, the limit has to be some type of ratio. Fair enough? From your knowledge of trig, what is the biggest possible ratio that, regardless of what's in here, the sine can produce? 1. Beautiful. If you forgot y, think of what the graph of y equals sine looks like. It's an oscillating graph whose maximum point is at 1 and whose minimum point is at 0. So guess what? This is not starting to look like something like this, where I have my sine squeezed in between two things. Now, I didn't put what I had here, but I can have anything in there, right? I know that I have a problem, right? But does the limit care about what's happening at 0? No. Just what it's approaching it. So that's why I'm putting that 1 over x back in, right? Okay, so that's not what I'm taking the limit of. I'm taking the limit of this times this. So what do? How do I make this show up in the middle of that? Multiply everything by x, okay? Negative x is less than x sine 1 over x, which is less than x. Is the middle matching exactly what you're trying to take the limit of? Yes. Perfect. So now take the limit of what? According to this. Take the limit of the two things that are on the outside. And if they happen to be the same value, then logically whatever's in the middle is going to be the same. Let's check it out. What is the limit as x approaches 0 for negative x? 0. And what is the limit as x approaches 0 of x? So if your function happens to be in between those two values, there is no value in between. What is it? 0. And therefore, limit as x approaches 0 of x times the sine of 1 over x is equal to 0 by the squeeze theorem. Someone asked me in a previous class, do you expect me to say that? I don't. AP exam will, if it's a free response. If it's a multiple choice, they don't really look into that. But if this was to show up for some reason in there, then I would have to say, justify myself how I got it. Fair enough? Okay. Do you have any questions? I mean, honestly, to me, like the squeeze theorem, whoever, I don't even know who created this personally. It was just observation. I think it's just kind of common sense. I think what's difficult about this, and what every year I see from students struggling, is like, how do you come up with the functions that are high? Cool? So, I give you some practice, you get stuck, you let me know. Cool? Alright, other than that, any questions about anything that happened today? Yes?
So, when you're taking the limits of like the top and the bottom function, if the numbers don't line up,
then I cannot say anything about the middle. You're with me? So in other words, you were not able to solve this problem using this squeeze theorem. Cool? Good question. Anything else, guys? Okay. Thank you.